This is products. Last lesson we looked at last lesson we had a look at sigma notation, which was series, where this meant sum everything together.
There you go, Nicholas. Or remove your AI extension.
So that meant sum every term. This guy over here, this is the capital Pi. This means multiply everything.
So it's like sigma, but you plus it. But you opposite.
You product it.
Yeah.
So you multiply every, oh sorry, not product, term. Multiply every term in the sequence together. It functions very similar to the sigma, so the series where you add, but rather than adding, you turn the, like you push the plus symbol 45 degrees over, and it turns into multiplication.
Is our next test just on the induction, or is it on something else as well?
You'll have to look at the next thing, next lesson. We're doing some trig with this.
I don't get it.
Okay, so what we're going to do is we're going to use this as an example of how you can prove product proofs. Again, I don't believe this is part of our course this year, but we're doing it because we've got time and it will help you immensely for next year if you see it once at least this year. So we're going to prove this. First thing we always do is we're going to define this as P of n, or you could do it as P of little n. So P of n in this instance is going to be the product of I up to n, where the expression is 1 take I plus 2, all under 2, and that sum, or that multiplies to uh-oh.
Oh, no, that's maximum.
Come on in. You gotta walk behind that so you don't walk in the frame. Okay. So this is our P of n. Whenever we're dealing with these from now on, we're going to start defining them as our P of n. First step when we're trying to do the proof is we will do what case, please, Claire?
Base case.
Base case. Base case is always the first case.
Do base case first. Wow, good job.
This is going to be P of, Nick, P of what?
Pick one.
Why 1?
Because it's easy.
It's all positive,
It's a positive
integers.
integer.
In the textbook, they usually use 0 for the base case.
Why don't you
Yeah.
use 0?
We're not doing that.
Yeah, but why do they?
I don't know. It's like a mathematician's argument. They're trying to argue that 0 is a positive integer, but it's not.
That's kind of dumb.
It is dumb. 0 is neither.
It's a placeholder.
I mean, they do have a point.
Don't get into it.
They got a point because you could say 0 is a natural number, and all natural numbers are on the integer number line. But it just doesn't fit.
Have you seen Young Sheldon?
No. Okay, so base case is going to be when n equals 1. So our left-hand side is going to be the product of starting at I equals 1 all the way up to 1. Like so. Evaluating this, we simply sub in 1 for I. It's going to be 1 take 1 plus 2 all over 2. And then this is 3, so it's going to be 1 over 3, take 2 over 3, and that's just 1/3. Sorry, no, that's 3 over 3.
How come you use I instead of n in like the I equals 1 and that?
Okay, this is where you start.
So why?
This is where you're going up to. When we sub into 1, our upper limit is
1.
1. So we're starting at 1 and we finish at 1. So every time we go through one of the members in the sequence, we sub in I equals 1, I equals 2, I equals 3, all the way up to I equals n. In this case it's 1, so there's only one member in the sequence. Does that make sense?
Yeah.
Okay. Good question though. I get it confused as well sometimes. Next one is going to be RHS. That's a nice simple expression that we sub 1 in for.
Something easy.
Sorry, that should be a plus here.
Yeah, I know.
I got 86.
Guys, sorry. That should have been a plus.
Oh my yeah.
I just wrote it wrong. Could you make that amendment to your book, please?
Yes.
Okay, that's 2, that's 2. Sorry, it's a plus 2. That's 2, that's 3. So this is going to be 2 times 3 all over 2. You can play keep or kill. Kill the 2's. So it's 1/3. So your left-hand side is equal to your right-hand side, which tells us, what about the base case, Mr. Sweet?
That's true.
It is true. So what should we write?
That P1 is true. To the case.
B1 is true. Now, after we do the base case, what case do we jump into, please, Ash?
Inductive case.
Inductive case.
I'm not celebrating about knowing the names of the cases later. If you don't know the names of the cases by now, you'd be a bit appalled.
It
I thought it
happens.
was pretty bad off. So.
Okay, because we make the assumption that P of k is true. So P of k in this instance is going to be the product of I equals 1, 1 take I plus 2 all over 2 equals what letter do I need to sub in here, please, Mad Dog?
Huh?
K.
Yeah.
And then K and K. Be careful not to put a K in for the I. That's another mistake I always make. You'll get to see me make it soon. And because of that, hence, P of K plus 1. So your right-hand side is going to be, this is what we're working towards. K plus 1, plus 1, K plus 1.
Shouldn't it be K plus 2?
You're right, it should be.
Volleyball.
Don't have any, but you win the praise.
That's
Good job,
all I
Ash.
need. Thank you.
All right, so the right-hand side is going to be that. That's what we're working towards. The left-hand side, on the other hand, is going to be the product of K plus 1, counting from I equals 1, 1 take I plus 2, 2, like so. Now, what did we do with the series to get into this question? Because it's not workable as is. Anyone remember? Lenny, you look like a guy who remembers stuff.
We split the left-hand side into the k plus 1 and the k.
Yep. So we kick out the k plus 1th term in the sequence. So that's going to be 1 take, and then for every I it's k plus 1, plus 2, like so. that cool? So the k plus 1th term. From there, we use our p of k. That's going to become, this guy over here is our p of k. So subbing that in, it's going to be k plus 1, k plus 2, and then upstairs it's 2 plus. And then, before we go any further, with the k plus 1th term, we have 2 terms inside the bracket. What we're working towards is a single fraction over here, where numerator and denominator, denominator is k plus 1 plus 1 times k plus 1 plus 2. What do you think we should do if we have 2 terms in this second product here?
Simultaneous equations.
We should try and write it all as one big fraction. Now, denominator is k plus 1 plus 2. How can we write 1 with a denominator of k plus 1 plus 2?
Times the top.
Yeah, firstly pretend it's a fraction by putting it 1 over 1. Then, what we're going to do is we're going to times k plus 1 plus 2 over k plus 1 plus 2. Do you guys remember this from year 10? Start of year 10?
Yeah, I still really remember it.
When that, well, 1 is equal to anything over anything, so you can say that 1 is also equal to k plus 1. Plus 2.
Alright, and now I've made a mistake on the board, but I've been trying to act really cool about it. Where have I made the mistake?
When
Using
you
red
substituted
marker.
k plus 1.
You're adding them instead of multiplying.
Yeah, I gotta push it 45 degrees over.
What are you? And down there.
I was just checking to make sure anyone would
Is
notice.
it down there as well?
Yes. Is it when you're using
There we go. Alright, now, next step. This is a little tricky. I want to save space on the board. What we're going to find is that you can just ignore the blue, and you're just going to deal with the fraction in red here. We've got k plus 1 plus 2, and we want to take away 2.
What
Rowan?
goes next to the equal, like up where you wrote the,
Here.
yeah,
That's for all.
so there's no variable that goes in?
Go on, Rowan.
So there's no like, n or k that goes in?
I was waiting for someone to tell me to write it there. Well
Yeah,
done.
right.
You win the praise.
Yeah.
Okay. We've got k plus 1 plus 2, and we're taking 2. The effect is here is that this plus 2 and this plus 2 cancel. Sorry, this plus 2 here and this take 2 will cancel out. So what we find is that on the next line, it's going to become stop yawning.
And is that you?
Yes. I was
tired?
for a second there.
Is that late night or something?
Not really, no.
Stay up.
All right, that's where we are.
Yeah.
Now, next step, we've got 2 fractions that are being multiplied together. What should we do?
Calculator.
Just multiply them together.
You're on. You actually works off the man.
Very single correct. Oh.
Yes.
Simultaneous equations.
All capital.
Ron, you should have been doing that the whole time. This is general knowledge, putting a K there.
Yeah, and who's making something correct?
Okay.
How was that
Yeah,
going?
but we didn't need to. I didn't even know what was going on.
No, you don't.
No, you don't.
No, you don't.
Big sway doesn't.
All right, we are so close here. So close, we're basically
That's so
done.
close.
It's like a whole page.
Now, what are we expecting upstairs? What are we expecting upstairs? Just the 2. What do we have hanging with the 2?
Oh, K plus 1. Oh my god, kill or kiss or whatever it is.
Keep or kill?
That's the one.
Keep or kill? We want to keep the 2. We want to get rid of the k plus 1. We're dealing with fractions here. There's a single fraction, single upstairs, single downstairs. The only logical way to kill is to cancel out. We've got a k plus 1 upstairs. What do we have downstairs?
K plus 1.
K plus 1. What are we going to do? Keep or kill?
Kill. We're gonna kill it.
Aggressive.
Kill.
Yeah. Yeah.
We kill. Okay, awesome. This is going to give us 2 upstairs. That's what we wanted. That's what we wanted all the time. Plus 2, k plus 1, plus 2. We are so close. We're basically there. We're expecting k plus 1 times k plus 1 plus 2. What do we need to do?
Split the 2.
Split the 2 into a 1 plus 1.
Yeah. You give that something.
We've been doing it the whole time.
No. No, we haven't.
Yes, we have.
Hence, k plus, or right hand side is equal to left hand side. Hence, p of k plus 1 is true.
Well, left hand side.
Now, to get your final mark, what do we need to do? Please, Isaac.
Therefore, since P1 is true and PK plus 1 is true when PK is true,
What's true?
then
Just say it's all true, right? Yeah.
then PN equals
That is what?
is true.
What did you say?
A.
What did you say?
No, you don't even know what you're talking about anymore.
What?
You don't even know what you're talking about anymore.
I know what I'm talking about.
You like my
I
mum?
know what I'm saying, so
I went there.
I'm listening.
appreciate it.
You're okay.
This is 16 years ago. When?
There's your final mark.
The whole thing?
What's the name?
Yeah, so since P1 is true since P1 is true and P of k plus 1 is true, whenever PK is true, then P of n is true for all n.
So if I don't have if I like don't have a clue how to do the question, I just put that, I get a mark.
Maybe. If you don't know what you're doing, Nick, just make your handwriting a little bit tricky to read.
Looks at
That's
me.
a good idea.
Like, get a bit chaotic, cancel a few things out, voila.
And then write that.
The marker doesn't have time to spend 10 or so minutes on every
That's what-
person's
in the
question.
methods test, I did some stuff and then, because it was like a show
It's on
question.
film.
Like what?
It's on film.
Yeah, it's already.
We can talk about what we have done.
Yeah, we
Sorry,
are.
we could talk about what we could do, but not what we have done.
Why not?
You can always moderate it.
Nah, because it's okay. Like, I got told to show something.
Yeah.
And I wrote a few things down and then just wrote what I had to show.
Oh, nice.
And I didn't get full marks.
Oh, so why are you telling us this?
I wrote down what I was meant to show, so it shouldn't have
Alright.
full marks.
The point is, if you don't know what you're doing, just look confident. You know what you're heading towards, so just break a few rules. If you're convincing enough, then you'll get the marks. If not, you'll lose a few. But you're going to lose a few anyway. The strategy for these questions is, remember, this is a product. It's actually probably easier than a series because you're multiplying everything together. You're going to have less fractional complications and calculations. For these, so it's always multiply. The strategy is the same. You sub in P of k when you split the product in half. And I believe for this one, because we're dealing with something like this, the algebra we employed was representing 1 as this sort of fraction. So you get the denominator and put it over itself. Is that cool?
Yeah.
Do we understand everything on the board?
Yep.
What part don't you understand, Mr.
The
Sweet?
box.
The
The orange
box?
box at the bottom, why have you put it to normal
Here
K?
and here?
Nah, just the bottom one. So
Here?
you got K plus, no, the orange box. That
Yeah?
one, yeah, so you got K, but not K plus 1.
So this was K plus 1 here.
Yeah.
So it always goes 1, 2, 3, 4, blah, 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 K, K
Yeah.
plus 1. So I said, I don't want to be at K plus 1. I want to be back at K. To be back at K, I boo the K plus 1 term out of the product.
What?
So I booted the K plus 1 term outside of this product here. So I wound it back
So
to
we
K,
instead
kicked
of
out the K plus 1. I kick it out by getting this formula in here, or this expression 1 minus 2 over I plus 2. And every time I say I put in K plus 1.
Okay.
Does that make sense?
It's still K plus 1 though.
Where?
K plus 1 plus 2.
Here?
No, the next line. Yeah.
Here? Oh, here?
Yeah, just, yeah, something like
No, because this is the K
that. Yeah.
product, and it's equal to that.
Oh, okay.
So I can sub that in for that, so it's there.
Yeah, I guess so.
Does that make sense?
Yes.
Yes, or you're just saying yes to appease me?
No, I'm just saying yeah, but
Alright, you
Maybe
might have
makes
to
sense.
practice a few until
I'm
you...
gonna have to practice.
Yeah. Anyone else? Any questions? Alright, cool. I think there's only